Hello, I'm Arnaud Wetzel. I'm actually the co-founder of a French company that gathers different inventories of all the French retailers and offers service on this search engine, this kind of thing, on these inventories. So internally we are using Ruby, Python, Java, C, and Erlang, mostly Erlang because we use React for our data, and so we added some code to React. So that's why we are doing Erlang, and so I'm interested in Elixir because it brings some flexibility to Erlang programming. So that's why I'm doing this presentation. So my presentation will show you firstly that Erlang is an OS. It exposes you some kind of virtual machines that is simpler than classical Unix system, and so it's a very fine execution platform with really good design goals, and that's why it's bad that not much languages are built in front of this OS, and I will show you why. First, why Erlang is a VM. A VM is why you do not want to construct a scheduler of or communication or I/O, because when you are programming, you want some abstraction from the machine, and that's why you need an OS. You can code everything right from a bare metal hardware, but you want to have some OS, and so you are using, for instance, the Unix kernel that implement many kind of behavior, like memory of processes, threads, processes isolation, shell memory, many complex concepts, because the goal of the Unix kernel is to provide you a maximum of feature with a minimum overhead coming from the platform, and the maximum interoperability with other systems. And that's the main goal of the Unix kernel, but it's not. I don't think it matches the most developed system, and so it shows you this many abstraction, like sockets, like virtual devices and this kind of thing, and it exposes you these different concepts with a standard interface, which is the same as file interface, but everything is not file in Unix, but everything is accessible with the same interface as file. It's not the same thing, but actually with the Erlang virtual machine, I think we can sum up the Erlang virtual machine with my first line. So it's a lightweight, isolated, auto-garbage collected, linked processes. So processes are linked to allow OTP platform, so to allow if one process crash, other process know it, but we can choose which process is linked to each one. It's not the case in the Unix interface. You have the memory is collected by process, and finally we want process. You want the process to be an abstraction that go over the abstraction of the process of the Unix process, that are totally isolated and that run inside one execution flow. The standard interface in Erlang virtual machine is message passing, not function call. And so every system in Erlang is SOA. So every system in Erlang is based on different states that you shared, and with only communication, we are connecting with each system, only communicating with them. And so the development platform of the Erlang VM have not the same design goal than the Unix kernel. The development platform targets high availability and orthogonality of concepts. So you processes as there are no threads, complex, different type of memory handling. There are only simple process, simple links, simple memory management by simple processes, and message passing. That's all. So finally, it's the same that Unix kernel, but simpler. And you are the developer, and you want to have a simpler interface. So what is finally a programming language? Finally, the programming language is the interface to this VM. So it exposes the VM, sometimes the same kind of VM, for instance, C or C++ expose something which is approximately the same as the Unix interface, but sometimes with some add-ons. So for instance, JVM expose you a VM, but which allows you to automatically manage your memory, on to link your function with data structure with classes. But actually, the real OS behind this is the same abstraction than the Unix kernel. So threads, processes. You have not a higher level abstraction. And so the VM is the ease of design. So it's a functional abstraction of processes or small processes and what is the interface. But language is the ease of design implementation. So how will you communicate with this VM? And that is the point. That is my point. So Erlang is a great execution platform, but the language is kind of really simple and offer not so much flexibility. And you as a programmer, you want to have this flexibility that you have with other languages. And so, for instance, Ruby. Ruby is about ease of programming. Ruby allows big flexibility to communicate concepts to a point where code representation matches business representation. So it's what we call a DSL, domain-specific language. But actually, when you add some function in Java, you are increasing the Java language with this new function. So it's a DSL. But what we call actually DSL is when the business representation has to match the programmer representation. And it's not, it's sometimes useful, but not every time. But it can be useful, and you have to have the flexibility to build your own DSL over the standard representation that the language designer gives you to communicate some concept. Sometimes in front of you, you do not have an Erlang programmer, and so you want to communicate your concept. So that's why I think Elixir is good. Because Elixir shares Ruby design goal, it brings flexibility to Erlang virtual machine. So it's a language toolkit over the Erlang VM and data structure. So in Elixir, the data structures are the same than in Erlang. So you have atom, list, tuple, binary, int, float, anonymous function, and that's it. It's exactly the same. But what is Elixir? Elixir is an IST. Elixir brings homogeneity. So Elixir brings an IST, so you can describe Elixir code with an Erlang data structure. And Elixir is only this IST with a function, def macro, that compile the Elixir code from this IST. And that's it. And then we have a simple orthogonal syntax over this functionality. And then little well-defined syntax shortcuts to allow you to have this kind of IST programming, but simpler. And then a simple and consistent standard library that bring you the things that you missed when you use Erlang. So, I will give you a small overview. Elixir is that. So, everything is function, is Elixir. It's a really orthogonal language. So even the module, when you describe the module, you just execute a function that takes the atom describing the name of the module, then a prop list with containing the IST of the function. Def is also a macro that compiles the IST, so it's the IST of the prototype, and then it's the code bucket. So it's here, it's the code to it's the multiplication function. So then Elixir add quote and unquote to switch between the two representations of the code, your representation and the IST. So you can take this and replace this one by quote do and quote do function multiplication. Then Elixir add a syntax to add aliases to atom. So when you have the first letter uppercase, you can this is exactly the equivalent of this, and then you can alias it and create many aliases like truck here that will be converted into the atom. Then many parentheses here. So we want it to be more simpler. So we make the parentheses optional. That's all. It's necessary because it's quite hard to read here. So we remove the parentheses. Then we add infix operator. So the multiplication function, we replace it with x and y, x and y in each side. And then, finally, this is the final representation. But it's only function code. You describe your code only with function code. So it's really powerful because you can dynamically create your code. But in the end, it's the same Erlang code which will compile into a Beam code. It's exactly the same. So what we saw, function everywhere, syntax choices. So it's more mainstream than Erlang prog type language. It's Ruby inspired. The instruction separator is new line, so you can do copy paste. It's really useful because you cannot do that in Erlang, and it's quite frustrating. Then a small shortcut that you can replace a prop list that you use in Erlang many times. So it's a list of tuple of 2 elements with the first element, which is a symbol to which is the key of the value. And then this syntax could be write with this syntax. So a key key value. So this is what you use there. You see, here is just a properties with do. It's a kind of implementation to have a keyword argument like in many other languages. It's kind of practical because it's not necessary to when the last argument is a property list, you cannot brackets are not mandatory. Oh. And finally, two little syntax shortcuts. Do parentheses can be written with do and end. And finally, automalysis, and that's it. So it's really simple IST, really simple syntax with only function, and then a little bit well-defined shortcuts to allow you to have a more simple code. And then, in addition, we have a very good standard library with an undefined library for everything which is not quite standard in Erlang are unified with the Elixir library. First, when we have something that can be enumerated, all indexes are 0. In the Erlang library, sometimes it's 1, sometimes 0. Can be. And then in Erlang, you use sometimes a string as a list integers that encode the string, and sometimes bare metal binary string. But it's an inconsistent way of working with string. Some library use one representation, the other one. Elixir unifies the thing, and everything is uses with binary string, and you have a module that unify this with this string. Then useful little macros like pipe. I don't know if you want it. I will show you that after, but it allows you to take the argument of a function and put it behind the function in the code. Gen server behavior, for instance, when you write a Gen server, every time you write the same line of code. Gen server behavior is only a simple macro that just writes the code every time you use this behavior. So it's really simple. And then useful bigger macro like protocol or def records. When you do Erlang, you create a data structure. And then every time you create a module that will access and modify this data structure. It's a common way of doing things. When you use Elixir, you can use def record that will create a record, so a data structure, and then create an associated module with a standard function to access and modify this record. It's just easy. When you use Erlang, you just code it again and again every time. Protocol, it's a way of dispatch horizontally your code. When you want to abstract a kind of function, for instance, enumeration, you implement a module for your data structure, another module with another data structure, and then every time you implement a module that will dispatch your function between the two kinds of data structure to share your code. When you are doing Erlang, every time you write the same module. With Elixir, you have a simple macros. It's only macros, def protocol and def implementation. Def protocol will define the dispatch module, and the behavior that the implementation module has to implement and then def implementation check that the implementation is good and is called, and create a module that will be called by the root protocol module. And finally, standard library bring some protocol like enum, set, dig, stream, a template library included in the standard library, a project management system mix, which is really useful. Benoit shows you Wiba, that is a separated project management library, but it's Basho from React developers developed this tool, but it's not in the standard Erlang OTP. A shell with colors and nice shell, but it's only an addition from the Erlang shell. It's only Erlang shell with Elixir inside. And finally, a little unit test framework. Then I will show you a small example of macro. So this is the pipe operator. The goal is to, when you want, for instance, you have the sentence, you are okay, you want to take each word, reverse them, and join them to have okay you are. In Erlang, you are doing join, reverse, split, you are okay. The second argument of the join. It's not really practical because what you mean is actually, you are okay, I want to split it. I want to reverse the word that are split, and I want to join the word. It's only argument inversion, that's all. Really simple. You are okay, so it's here, you are okay is put as an argument in split. Then this is put on the argument of reverse, etc. Very simple, but very useful. You cannot do this in Erlang, but simple. This is Elixir standard library. This is the definition of the macro. It's really simple. Def macro, left, pipe, right. What we take, we fold, we convert all the elements that are piped. Then we convert them in a list, so we have all the AST of that in a list, and then we pipe, unpipe, we convert all the instruction list, and then pipe will insert everything in the list in the right order. So here it's AST. Def macro just return the AST, so it's really in one line of Elixir code to have the pipe operator. It's really practical. And then I will show you an example more big. So this is the implementation of a nanoring. So this is what Benoit shows you just before. So it's the implementation in Elixir. So it's one file, yeah. Because in Elixir you can put your module. It's only code, so you can put them in files as you want. You are not forced to take your module and put it only in one file. It's a little thing, but it's also really practical. So here, I define the application. The advantages of Elixir is you can list your module definition. So here, defining the supervisor here, you actually define nanoring.app.sup. And so you can show, you can write your supervision tree as a supervision module, as a module tree. So it's when you read this thing, you can read what is launched when you launch the application. In Erlang, when you are reading the first time the code of RabbitMQ or React, you have 2 hours to understand that what is launched when I start the program. You have 10 files to look, and it's really annoying. So here, module tree is the supervision tree. So I'm doing things like that. I don't know if others do that, but I think it's really practical. Because then, when you call this supervisor, you call actually nanoring that add you. So you know exactly where is placed, where your process is placed in the name of the module. Then I want to create a structure that allows you to. I don't know if you know CRDT. So some of you know, not at all. So it's a kind of set, but a set that allows you to merge different states of the set in a distributed system where you are not sure that the set is consistent. And so you can merge, you create a type of structure that can merge easily. And so here it's a set where you have an add set, a remove set. In the set you have the element and the set, and the time where when you add the element. And then to know if an element is in the set, you are looking the last time when you add the element, and then this time you take the last one, the last removed of the same element, and you look if the element was removed then. And so the put, a delete, and a union to this set is every time a union. Every time. That's the concept of CRDT. And then, when you want to read the set, in Elixir you just have to implement a reduce function, which is the implementation that you have to do to match the enumerable implementation. And so here, the reduce function is just, I take the add set, the remove set, I sort them to have the by date, and then I take the last one by one the element in the add set and look at if the element is present in the remove set to know if it's present or not. So if it's present, so it's in the remove set and the date of in the remove set is after the time in the add set, then, sorry, then I do nothing. I do not reduce because the element is not there. But if not, I can add. I can reduce. So take the accumulator on to the last state. And so I have just implement the reduce function, and then I can use every function of the new module to join, concatenate, find, split the set. It's you are used to do that in many languages, but in Erlang it's not so easy to share this implementation. It's really practical. And then this is the running example. So here it's a different for node, and then it's the same. Sorry, I didn't show you. Finally, the gen server that is running actually sends itself a message every second, a send gossip message, and every time it receives this message, it chooses in the node list a random node, send it its set of node elements, and then when you receive, sorry, when you receive the ring from another node, you merge the node list from the other set. And because every set are CRDT, you can have a distributed creation of the set. Because every time the merge will include the remove which occurred on one node in another node. And that's it. And then the demo is actually the same that the other one. So the practical thing is you see, you can do LS. The shell is more user-friendly because you are used to use the new line to pass to the other instruction. So here I can call a gen server nanoring. So here I send the message get up and wait. I'm waiting for the response for the server. So here you see. Here you can see the complicated structure as a simple list. How? It's easy. There is also an inspect protocol. You have to implement the inspect function that will implement the way that you convert your structure to show it in the shell. So really useful. And then here you see, I just map. I can do map because I implement a new module, and then join. That's it. So okay, that was it. So that's it. Do you have any questions about?
What has been the Erlang community? I don't know what size it is, but this is how new this is. First and second is how well received has it been in the Erlang community.
Actually, I don't
it's
think
a tough question.
That's a really good question because I think unfortunately the Erlang community do not integrate very well this language. But because the main problem is you have to understand all the advantages of Erlang to understand why Elixir is useful. But the Erlanger themselves are try harder to convince people that Erlang is good and Elixir is another step. But I think it's easier to convince people to use Elixir than Erlang because it's really much more flexible. And when you are someone using Python, Ruby, and or PHP, when you show him some Erlang code, he think, no, I don't want to forget all my concepts to match this kind of thinking. But the real kind of thinking of Erlang is not syntax. And if the syntax is something that people are afraid of, it's kind of really difficult to make the language mainstream.
Can you go back to your code example? Because maybe I can make some remarks on this observation.
Okay.
Yeah. Or can you go to the
Gen server?
Gen server, yes.
There.
So, yeah. So the point here is that, as you said, you have to know Erlang to use Elixir, because what you're doing here is you're using Gen server behavior, which is a behavior in an OTP platform for a generic server. And a generic server has generic code and application-specific code. And so you only have to implement the application, your application-specific code, and generic specific code takes care of distribution and a lot of useful stuff. So what you do here is you start implementing all the stuff that's in a generic server. You're implementing a handle info, which is a callback for out-of-band messages. You're implementing a handle call, a handle cast, which are callbacks for synchronous and asynchronous requests. And in the end, what this code is doing is actually calling a wrapper that is itself calling the real OTP framework itself.
It's exactly the OTP.
Yeah.
In the end, it's exactly the compile code is exactly.
So basically, you actually need to know how to do this in Erlang to be comfortable writing this here. The other thing, and I would actually like to see that. The other thing would be if Elixir guys would go ahead and start implementing something like the OTP framework themselves, and maybe with some new thinking or some improvements. That would be awesome. But this is just, I don't know.
Actually, that was in this demo. That's why I did that, because this part shows you Erlang, and the previous part shows you Elixir. So actually, the Elixir addition is just that. The other one is only simple Erlang. Simple.
Maybe we can show the Erlang version if you want to
Yeah,
compare.
it's a good idea to see the. I don't know how we can.
If you see the version on top here, where you define the function, and the Reddish function here are doing some magic that with the pipe getting the rem lights at the end. So if you are doing some okay.
Okay.
So this is the same module in Erlang. So I'm doing the add, which is the put for him, with a tuple. So I'm creating two sets, one for the update, one for the remove set, and the add an element to the update, the delete, etc. And if you see the radius, which is in Erlang, this is a difference. Yeah, this is bigger, but here you can understand what it does in the Elixir code. So you have the first thing the Elixir code does is reordering the list and making each element unique, then passing it to another radius functions. And where is the pipe here? So here you have the radius functions iterating over the added elements. Here we are iterating until we go at the end of the line of the list. And where is the pipe? The pipe is here.
Actually, this function is in the Erlang, is in the Elixir standard library enum, and that's the difference. You reuse.
This is perfectly clean.
Yeah, and this is the Gen server in this pure form. So the difference. We have two modules here.
Quite the same thing, actually, just different. The main difference is here you can only interface with the structure, with the function that Benoit defined. With the Elixir implementation, you can use even if
except if I write a macro.
Yeah.
Okay.
That's it.
And how new is it? I mean, is it how? The question is how beta the Elixir is. How stable?
It's quite mature.
It's quite mature.
But because yes, the language was created 2 or 3 years ago, and there are already books about the language. Some little details are changing between the version, but actually the thing that some little thing change make it impossible to build a big project with many dependencies, because every dependencies will not follow the changer. But if you want to code a little library with no dependencies and a little code base, you can use Elixir instead of Erlang. Actually, in my company, I'm using Elixir, but only as a OTP application builder. In the end, the OTP application that I built in Elixir, I integrate it in my Erlang application.
Yeah.
Because my big code base in Erlang, I don't want to switch to Elixir because I don't think it's a good idea, because the language is not enough mature.
Okay.
But it's nice.
Yeah.
And in addition of my nano-ring module, I also code a supervisor ring module that actually takes the same interface, the same OTP interface and, as supervisor, but the children are distributed with DHT, and so you have some kind of a global process creation and global supervision, and it's 200 Elixir, 200 line of code of Elixir, but it's really nice because it's using Erlang kind of error management. That's it. And then you can use my library is in Elixir, but then the name of the module is just supervisor ring, and you can use it obviously in Erlang.
Yeah.
No difference.
Can you elaborate a bit on what happens when a process crashes? I think Benoit mentioned that there's some kind of recovery and there's
actually, when every process in Erlang is linked to another process, so a standard way of thinking, which is OTP library, is just to create a tree of supervision, and so your process, when it crash, is linked to the parent supervisor. Then the process will crash, and if it crash too many times, it's that the state around the process does not allow the process to live. So the supervisor himself will crash, and then its own supervisor will restart a bigger tree of processes, and so a bigger state. A bigger state will be shut down and recover. And so we try again to see if the children die again. If they die again too much, then the other parent supervisor die also, and then a bigger state recovery happens. And so it's a kind of a tree of a state recovery tree. So you build your supervisor tree as thinking about state dependencies between processes.
So where's where do you know which record got processed and which are left, or when you restart you can't reprocess everything?
When you restart your little process, it will restart to a state, to its initial state. Its initial state may come from another state.
And maybe you don't want to do the same transaction again because you already processed it before it crashed.
Maybe you can have another kind of recovery, because you can link processes as you want. So you can put them in a supervision tree, but you can also say, I link with this process, and when the process crashes, I receive a message. I receive a message with the information that this process crashed and the reason.
You also have different kind of supervisor rules. So you can set your supervisor to restart, or just wait, or you can give an order in your process. So if process 1 has crashed, don't relaunch the process 2 or whatever. So you can decide what you want to do in your supervisor.
The thing I want to get is you're processing you're processing transactions from, let's say, bank, whatever, you take money, put it from here to there, and then this somehow crashes at one point in time, and then you restart it, and where does it pick up again?
It depends.
Yeah,
it depends on where the state of your transaction child process crashed. Actually, when it starts, it takes its state from somewhere, a database, another process.
Don't think absolute recovery at the same point with the same state. Think consistent state of your overall application. So actually, if you're linking processes together, what you do is you say, you guys, you have to die together. So if one of you dies, all of you have to die.
Okay.
That is some kind of cleaning up, creating a consistent state in your application afterwards. Now, if you don't want link process to die, there's some kind of special signal called an exit signal, and you can trap that signal, convert it into a normal message, capture that message in another process with a lot of metadata about your crash. For example, your crash telling your crash process telling the external handler, well, I crashed at this point. What you probably should do is this and that, and I can even give you my state. And then the other process will handle all of this.
What do you mean if you say state? That's all the stack with all the stack frames, or what's state?
Stack trace.
It's the point of Erlang. It's to think your application as distributed state. For instance, when you write in Java a class, you want to isolate a state and give a little interface, which is a method, and that's it. But actually, the real state of your class is not, you cannot understand it because the state depends of the state of all the other objects of your program and of the execution flow. But it's not the case in Erlang. You can isolate precisely your object and create your application is creating many different little and easy to understand states which are communicating each other with message passing. And so with this kind of state management, you can recover your application, recovering some parts of the state. So recovery, every process is a part of the state of the application. And that supervision tree is a kind of state recovery tree. You define how you...
Do you have a kind of, on the web, can one find kind of example where you can run the code and look at the code and understand what happens when it crashes? I mean, you know, just to see the thing in action, just to see, okay, now the transaction crashed here and now I restart and I'm in that state and I continue like that.
You can I can show you the code of React, where this the database, where it's a really good example of state recovery, but that's the program of Erlang. It's quite complicated to understand the entire code, because the syntax and every file you need to understand every process make it really difficult to make a demo. And
that's fine.
That's
so I mean, so for instance, React would be if I have 2
Yeah.
weeks to learn
Yeah.
free, it would be a good example.
It's a good example to start.
Okay.
React core.
It's hardcore, of course, but it would be a good example of self-contained.
And also some part of RabbitMQ.
Yeah.
And yeah. But I prefer React.
Right. Okay. Thanks.
But
That's awesome.
it's kind of. I think if it was written in Elixir, it will be more consistent.
Okay.
We have this little video that was made in March in San Francisco that explains well what is Erlang, how the crash recovery works, etc. etc. So some of you already showed it, I think. But,
okay. I don't know.
So we vote at the end. It's muted down there. No, it's muted on the YouTube is muted.
YouTube is there.
Yeah. Crash him and see if he recovers.
In Erlang. Hello, Joe. Hello, Mike. Question. Does anyone care about the differences between declarative and imperative languages anymore? Don't be silly. The declarative-imperative debate is always a crowd pleaser. From what I can tell, kids these days are going with what's cool, like Node.js and Ruby on Rails. Let's ask Robert. Hello, Robert. Hello, Mike. Joe's back to talking about declarative languages again. I just think Erlang's got a problem. When its spokesman is an old fuddy-duddy. Hey, Joe. Bite me. Robert, what do you think?
Erlang's the shitter, but I can't blame kids for picking something a little less crusty.
Erlang's image is stuck in the 1980s. It's the banana-rama of languages. Okay, tell you what. This is bullshit. If kids these days don't want to use Erlang, which is the real rockstar tech, then fuck it. I'll turn this video off and go home. Take my 9/9s with me. Joe, I didn't mean anything by it.
Yeah, Joe. Mike was just trying to be constructive.
Joe, turn the video back on. I won't have Erlang disparaged.
Yo, yo, yo. I can totally help you geezers.
Who said that?
All Erlang needs is an image upgrade.
That's very interesting.
Lots of things from the 80s are cool. Just look at Erlang and Super Mario Brothers.
What the hell is that?
It's one of those Ruby hipsters.
Watch it, Grandpa. Just because I carry my Mac. Wasted nose rings doesn't mean I use Ruby.
I, for one, am interested in what the little girl has to say.
Yo, first we have to fix the name. A language named after a 19th century Danish mathematician is about as cool as having a Facebook account.
It's just like the olden days. When Erlang was banned, we had to change the name.
That's right. When Erlang fell out of fashion at Ericsson, we changed the name to OTP. 3 of the trendiest names we could think of. Open. Telecom. Platform.
Gives me the chills just thinking about it.
Okay, that's bullcrap. No one cares about telecom platforms. We need something fresh, something edgy.
Like Erlang on Rails.
Jesus Christ. The last thing you want to do is imitate. No, something original.
How about Erlang++?
I got it. We keep OTP, but with a edgy twist. Check it. Your language will hereby be known as Allah, Techno, Psycho Bitch.
It does spell OTP.
Don't know what it has to do with software. What do you think, Joe? I absolutely love it. That name is fucking gangster.
Yeah, Joe. You rule. Okay, next thing we need is a video that is just as cool as the original Erlang the movie, but speaks to today's programmer hipster. I'm thinking something like this. bitches. Rex here. This time I'm talking about a badass new language called Outlaw Techno Psycho Bitch, or OTP for short. So, you all know I'm a huge Ruby fan. Ruby gives you 15 ways to do the same thing, and freedom of choice is good. Then I realized that's just 15 different ways to create really slow, crappy programs. Then I started using Node.js. I like those because, as my hero Ryan Dahl says, it's like coloring with crayons and playing with Duplo blocks. But as it turns out, it's less like playing with Duplo blocks and more like playing with slinkies. Slinkies that get tangled, impossible to separate. So then I checked out Outlaw Techno Psycho Bitch. It's a language out of Sweden that can be used to build web scale, asynchronous, non-blocking, sharding, event-driven, message passing, NoSQL, reliable, highly available, high performance, real-time, cost-durable, badass, rockstar, get the girls, get the boys, impress your mom, impress your cat, applications. Ryan Dahl, my hero, says we should not be supporting more programming languages than we should be killing them. That all these bullshit projects are confusing people, but Psycho Bitch is just so damn cool, I couldn't resist giving it a try. The first thing Psycho Bitch kills off is curly braces. Thank God. After a half-century of curly braces, we need something that's fresh. Psycho Bitch uses single character block delimiters, like in sentences. My hero Ryan Dahl says math is not necessary, that people who think it's superior to curly braces are wrong, but...
Freaky. Sometimes.
Psycho Bitch uses single character block delimiters, like in sentences. My hero Ryan Dahl says math is not necessary, that people who think it's superior to curly braces are wrong. But I figure, if math can get a rover to Mars, maybe it can help us write better programs. Psycho Bitch gets pretty uptight about logic. If you say that x is 1, and then turn around and say x is 2, Psycho Bitch goes apeshit. She's like, what the hell? When did 1 start equaling 2? Psycho Bitch has this great feature called pattern matching. You define the patterns, and if there's a match, your program keeps going. If something doesn't match, it crashes. Like assertions, but built in. What happens when your program crashes? Psycho Bitch has you covered. It monitors your code and restarts things that break. It's like the Terminator. You can blast it in the face with a shotgun. It stops for a second, then keeps on coming. I've written a chat server in Psycho Bitch. It's where all my friends and me can chat about how awesome Ryan Dahl is. Because the server is written in Psycho Bitch, it can easily handle thousands of concurrent users. Shit, did I say thousands? Because I meant tens of thousands. And by tens of thousands, I mean hundreds of thousands. I'm already logged in as myself at the top. I'll log in as another user. You say something using the tell command. The messages are received instantly, even though there are hundreds of thousands of connected users. I'll use the yell command to broadcast a message to every user. That literally sent the message to 300,000 users. About a second. Okay, 300,000 concurrent users is impressive. But even Node.js can do that. Let's try something hard. To make things interesting, we'll trigger a bug on the server. Damn, I must have said something bad. But as you can see, Mary and Jack can still chat. Of the 300,000 users on the server, I'm the only one affected. Let's see if we can fix the bug. Here's the code. Holy crap. It looks like the original programmer, in his zeal, added some forbidden utterances. Let's clean this up, because we don't want to censor. Okay, I recompiled the code. Next, I'll what's going on. Done. In case you missed it, here it is again, in slow motion. For some of you, what you just saw is not self-explanatory. With gracefully handling bugs, with hundreds of thousands of concurrent sessions, and fixing them in real time without stopping the service seems passe. You can always use Ruby. Then, when your app doesn't scale, move to Node.js. Then, when you can't maintain... Move to Node.js. Then, when you can't maintain your code because it's a pile of tangled slinkies, move to Psychobish. With that experience, you can appreciate what you just saw. For the rest of you, yes, that just happened. So, what do you guys think about Psychobish?
She's utterly terrifying.
It makes me wonder if perhaps Psycho Bitch is a real person.
You mean, is the name based on my experience with a girlfriend who's batshit crazy, drop dead gorgeous, brilliant, and brags to her friends about costing me tens of thousands of dollars in therapy over the last 3 years?
Oh shoot, I know a girl like that. She scarred me for life. Literally. Seriously, I'll show you the scars.
I think I can give you an example of what we said before. Here, for instance, if you want your player to be a photo referrer, to play, to work well than the YouTube player, you can have a server that is handling the last buffer size that is working. And then when you launch the player, it's another process. That's when you launch the process, it's initializing with the previous working buffer. And then you put them in supervisor. And then when this one crash, each time he is recovering with the previously working buffer size. And then if even the process crashed because the player stopped, then you recover the upper state, and then the server handling buffer size will crash also, and restart with the initial. So it's an example of what we said before. I think there are examples everywhere, but every time it's kind of difficult because it's a way of thinking which is really different. But I think every program we can be built this way.
Thank you.
Thank you.